Alright, so one of the items on my desk is what's called the alien clock. This is actually a pretty old object. My boss has had this for a very long time, and he really has enjoyed it, and he was telling me that it recently stopped working, and he didn't know where to actually find a replacement. And I said, well, I'll take a look and see what's wrong. Before we get started too far into that, he did mention that what was happening was, as you can see behind there's a bunch of LEDs. Basically, it tells the time in essentially binary decimal. It's a little strange. It's sort of, if you know how to read it, it makes perfect sense, but if you don't, it looks like complete gibberish. And what he said was that over time, it had started. The LEDs were starting to get dimmer and sort of flickering, and then recently, after a power outage, it just didn't turn on anymore. So I'm guessing that it's probably a problem in the power supply. We'll take a look. First thing up is, did the wall wart actually survive? Like I said, this thing's been really old, so let's just take a quick look. Should put out 9 volts AC at 1 amp. Alright, so plug that in to my Variac over there. I only use, if you don't know what a Variac is, basically it's a variable transformer. Lets you go from 0 to 110 volts AC. On this one, sometimes they also include step-ups, so you can actually go above the input voltage. I found this one at a yard sale. The main reason I use it is it does isolate, because it's a transformer internally. So I just use that when I need to do a measurement, especially on something that I don't quite know what's going to happen. It's a good idea that if you are doing a lot of work with mains voltage equipment, that you buy an isolation transformer. It does not have to be a Variac or other variable transformer. Could just as easily be a plain old one-to-one transformer. Let's see. There we go. So if I turn this on and do 1 and 1, we get 10.6 volts. Now, it's supposed to be a 9 volt AC, but it's unregulated. It's probably just a transformer inside that plastic, so 10.6 is fine. So let's turn our attention over to the actual clock. Looks like I have to take off this front plastic with some Allen wrenches. Can never find the right size. So what I'm really expecting inside here is, since we have an AC input voltage, the actual power brick from the wall is just a simple transformer, unregulated, which means we probably have to have a small power supply built into this board. Given the construction that I can see through the plastic, I'm expecting fairly simple, discrete power supply. And maybe we'll just get really lucky and it's a simple diode blew out or something. Okay. Yeah, let's go ahead and take off the DC jack it's not really DC in this case, but the barrel jack comes out. Great. So here's what we have. A stunning, incredibly dark green on black PCB. Or green on really dark green. Copyright 1992. So yeah, been around a while. Single-sided components on one side. Nothing special there. What's this part? Can I actually see it here? I know the lighting is terrible. Let me see if I can read this. Looks like a MC68HC705. So a old microcontroller. But what I'm most interested in is, if you look at the construction, basically the LEDs are all routed up at the top. And as far as the traces go, all the traces from these LEDs basically run down into these drive transistors here. And really, it's not that complicated. You know, the microcontroller is really just buffering. It's really just driving these transistors to drive the outputs for the LEDs. I'm more interested down here in this power supply, which probably requires a little bit of work to reverse engineer here. Power comes in there. Looks like we've got 1 or 2 diodes. What's going on there? Two diodes. It's gonna take a little while. Let me draw it out. Right, so that took a little while to figure out. So it's actually a half-wave rectifier with just a bulk reservoir cap and a bleeder resistor. It looks like then they go through an RC filter, and either this is a Zener, and I didn't look up the part number, or they're protecting against some sort of negative voltage. I'm guessing it's a Zener. And that's really just the rail that goes into everything for the low power side of things. The back here, there's also another tap that comes off for actually powering the LEDs through drive transistors. And this other fork here is that they take the AC waveform and use that to be your clock source. So they rectify this, run it through a transistor, which basically just pulls down a pin, and that gives you your 60 hertz reference, 60 hertz in the US at least, as your time reference. And that's pretty much it. So I'm guessing that this guy here, the big bulk electrolytic, has just died. Pretty common failure. So I'm gonna hook it up, do a few measurements, and see what's going on. But that's my guess. Okay, so we're turning on mains voltage. Now what my boss told me was when you turn this on, the default is that it turns on all of the lights in a random pattern, and that's just not happening. So if we look at the voltage across this here, I'm seeing 8 volts actually, so that's not terrible. It's actually surprisingly good. So if that's the case, 2 pins of the micro here are very clearly your power rails. Down here we have a ground and a power rail, and there's a solid 5 volts there. So actually our supply input looks pretty good. So it must be down that other fork. Now I traced this out earlier. I didn't draw it out because I didn't want to bother messing with it. But what we should see, if I'm looking at over here, this pin should be pulsing. It shows 2.5 volts on the voltmeter. I'd have to hook up to the scope to actually check for sure, but that does in fact seem correct. So that's interesting. Yeah, 8 volts there. And 8 volts at the LED. And 5 volts at the micro. How interesting. I have to think about this for a bit. Well, I started playing with it. My boss had told me, I forgot, that you need to hit the top button to actually get it to turn on. And once it's on, it just basically runs in a random pattern by default. And then you can hit the other button to actually have it tell time. And so here it's counting the seconds along the bottom in binary. Then you have your minutes and hours up here. But you notice that it's actually pulsing these LEDs. I don't know how well you can see that. But to me, knowing what I know now, it looks a lot like that there's probably a decent AC component on the bulk, out on the bulk rail. Yeah, see, I'm seeing about 3 volts AC, and even though, right, with everything on, essentially that rail, the half-wave rectified rail, just at the bulk storage cap, is now down at about 6 volts. Right, so when I look at this, we can see that the LEDs are kind of flickering, and he had said that was happening and eventually it stopped. So when I come in here and I look at the main supply rail, not the 5 volt rail used for the micro, but the actual bulk rail just after the halfway rectification, now it's down at 6 volts when it's actually running. And if I look at it with an AC, I'm seeing about 3.5 volts swings as AC. So essentially that cap is no longer smoothing, and so that cap is probably toast. So I don't think I have any radial electrolytics. I probably do have a 470 microfarad, but given how it's visible, we'll just see if I can make it fit. Anyway, easy enough fix. Hopefully that'll take care of it. So here we have a 470 microfarad 16 volt capacitor. I didn't have one of these on hand, and the only thing I had was a 1000 microfarad 10 volt, which it's not ideal. It's kind of pushing it on the voltage rating. I don't think I have any other options. Yeah, the only other option I have is overkill. 1500 UF 35 volt, which if I tried really hard it might fit. A little worried about height though. I was already struggling to get the other one to fit. Well, if nothing else, I can tell him that this will work, and if that cap fails, well, that cap fails. Yeah, normally I agree with the principle of it's a 9 volt AC supply coming in, you're rectifying that. It's halfway, so you're not going to get the full 10 volts, you're going to get, or you're not going to get the square root of 2 factor on it, so yeah, should work. But with that, before we get too far with it, let's go ahead and just check out that it actually works. And look at that, it powers up and the lights are good, and if I hit the buttons to set it, it actually starts working correctly, and it's got nice, solid, steady there. I checked, just because I'm a little concerned about the capacitor. Voltage rating. Oh, it's got 13 volts on it. Huh, the other one was just drawing too much. Yeah, so that's not really going to work. Like I said, I don't really have another option for that at the moment, so I guess I'll have to order a part. But it's good to know that that does work and that that was the problem. And we'll just get that fixed. Well, digging around through my drawers a bit more, I found a package that had the ominous C23 optional for headphone amplifier use only. This actually came out of a kit, but what it means is I have two of these very nice 1000 microfarad 16 volt caps. Also not really the radial kind, but hey, at least it's the right voltage rating and should work. Alright. power on and running patterns. Voltage on the cap. Are we within our 16 volt range? I hope so. Oh, right. Helps to actually measure the cap. We're sitting at about 12 volts. Yep. So, that's within our tolerance for... I'd prefer to be double, but whatever. Alright, well, I'm just going to put this back together then. Helps to make it where you can see it all. The delectable job of laying your axial on a radial down so it makes it look like a radial because you don't have any space. Don't recommend it. Do not do new designs. You would think I would have thought of that. I got that just the tiniest bit too close to that screw hole. I don't think there's a way to fix it now, because I already trimmed the lead. this barrel jack does not protrude very much, and so getting the retaining nut on is a little challenging. Alright, and with that, we should have a clock that apparently falls over. Because I put it on backwards.